also a master student, and here's my research topic. It's experimental approaches to estimate the number of clusters for marketing data. And my structure of this paper is that at first I will spend about 1 minute to refresh our memory about some well-established algorithm for us to use to do clustering. And the second part is most important. I want to introduce 4 methods for choosing the number of clusters. And the third part, I used our package called Uniclust to actually automatically choose the number of cluster for us, and which follows my final result. So first, I'd like to refresh our memory about some clustering method. The first one we have K-means. K-means is also the most widely used in the literature. And we also have some variation about K-means, like K-median and K-median, and so on. And if we sum the probability to each of our observations, we also have fuzzy C-means. And next, we also have EM, the expectation maximization, and also the hierarchical clustering, which is also widely used. And also among others like SOM and so on. So next, I would like to introduce some of the methods we can use to estimate the optimal number of clusters. So the first method is album method. It is actually a visual method. I use the arrows as an example. You can see from the right picture. The x-axis is the number of cluster we have assumed, and the y-axis can be the within clusters sum of squares, or we can also use percentage of variance and others. As long as it can be a monotone function. So you can see from the lower left picture, the arrows actually have 2 clusters overlapped. So we can either say we have 3 clusters, or we can see we have 2 clusters. So the advantage of the album method is that it is easy to compute, and it is also visualized too. So it is easy to understand. However, the shortage of the album method is that sometimes it is ambiguous to actually identify the album simply by visualization. And the next method actually is more advanced. We need to compute some quantity in order to calculate. The next method is actually called the survey. So actually, we need to calculate first the A of I, which is how far away our observation I is on average from other observation within the same cluster. So A of I measures how tight our cluster is. And after that, we also need to calculate how far away on average A is from other observation in the other cluster. And then we choose the minimum one as another measure is A of I. And then we simply use the formula to calculate the solid value of our observation. So next is solid plot. So after we calculate each solid value for each observation, we can have the plot like this. So the first column is actually the cluster which has been assigned to each observation. For example, our first 5 observations has been assigned to class 1, and the second 3 have been assigned to class 2. And the next column is the nearest neighbor to each observation. And the third column is each individual celebrated value for each observation. And the chart on the right is simply the length, or we can see the width of the celebrated plot. And after that, we can calculate the average celebrated value for each of the clusters. And after that, we can also calculate the overall average celebrated value. So we choose the number of cluster which is associated with the maximum overall average celebrated value. So next is an integrative example. So now we can see on the left picture that we have 4 well-separated clusters, and on the right, we can simply run many algorithms like k-means, and we assign k equals to 2, 3, 4, and so on. So we can see the maximum one is over there, and it's actually right. So our k equals to 4. In this case. Next is another example in 3D. We can see that we have a 3 well-separated cluster, and the Solvay coefficient chart is on the right, and the maximum one is also give us the right cluster number, which is 3. The advantage of Solvay method is that it is easy to visualize, and it's also simple to understand. And it only rely on the actual partition of the object and not on the cluster algorithm that used to obtain it. However, the shortage of Solvay method is that if you have a single cluster, we cannot use this method. And it also gives us little information about each individual observation. The next method is the gap statistic, which is the gap between the average Bayesian cluster sum of square around the cluster mean and our expectation under appropriate non-reference model of the data. So it is a test method which compares the evidence against a non-hypothesis, and it provides a statistical procedure to formalize the album and the Solvay heuristic in order to estimate the number of clusters. And it can use output of any cluster algorithm like k-means and hierarchical cluster. Next, we have some steps to calculate the statistics. I will not show you all of them. Which I want to mention is here. The last term is the statistic we can calculate, and the first term is actually the Monte Carlo sample from our non-hypothesis. So it's actually the our expectation minus the statistic. So the advantage of this method is that it can be applied to any clustering method, and it's more rigorous because it uses statistical method like hypothesis testing and so on. The shortage of this method is that we cannot always find a right non-hypothesis, which is not always the case. So we also have an information theoretical approach it is almost wholly non-parametric, and it's motivated by the field of electronic engineering, and it's simple to understand and compute, and also highly efficient on a wide range of problems. I also list the step to calculate it. If you are interested, you can see our note paper. So this is an illustration of the jump method. In this case, we have a 9 well separated cluster, and 3 of them actually are very close to each other. So the chart in the right, we can see that it correctly predicts we have a 9 cluster. However, you can also see a little peak here. So it can reflect the underlying structure of our cluster. So what I want to say is that actually we have more than 30 methods we can use to help us estimate how many clusters we have. I also list the 3 here. And my experiment is conducted by using our package called NB-class. And I list the code here, which is very simple. It's a package, and you can learn a lot of function you can use within the package in the paper of NB-class. So my conclusion is that here is a little example. So all the 30 measurements are graded that we actually have the number cluster of 3. So the first one I suggest is that we can simply follow the majority rule after calculating all the measurements. Or we can further investigate which one to use.